Okay, so last time we were able to solve for the equilibrium concentration of our species with the help of the ice table. Na? So the ice table allows us to track the changes of the the concentration of the chemical species initially, then as it goes to equilibrium, nakikita natin yung changes sa concentration. Okay, so to construct the ice table, you're going to plug in all the species that are in aqueous phase or pwede rin sa gaseous phase. Okay, so lahat naman ng aqueous or gaseous phase, those are the only species allowed in your ice table as you don't need to write the ano, as you don't need to write the concentrate the ano, wait lang. Nasa mid ako. As you don't need to write the species that are in solids and in liquid phases, no? Kasi hindi sila nagma-matter, no? Okay? So, isusulat mo everything that are in aqueous phase or gaseous phase in your ice table. You write down the initial concentrations. So, the initial concentrations are usually given. So, kung sino yung given, yun lang. Pag walang sinabi about that, make it 0. Okay. Then for change, you can predict yung change by determining the direction of the reaction by solving for the value of Q. And if you compare your Q value with your K, then pwede mo malaman saan papunta yung reaction, either to the reactant or to the product side. If the reaction is going to the product side, that means the change for the products will be positive as their concentration will increase, no, as the system reaches equilibrium. Okay. Then for the reactant, that's negative change. Okay. However, if your reaction is going to the reactant, your reactant side will increase as it achieves equilibrium. No? So the change for the reactant will be positive and negative for the product side. Okay. Then also we plug in dummy variables in our change because we don't know by how much will the system change, no? So dun tayo naglalagay ng x values kasi we don't know how much yung magbabago. Okay. So we plug in x here. Also take note that stoichiometry is followed, no? So yung stoic nila, sinusundan natin. Suppose this has a coefficient 2, then your change will be 2x. Okay? Yan. Because we are still governed by the law of conservation of mass. Okay? Then, at the E row, at the equilibrium row, you're just going to add I and the C. Pag-add mo lang sila, and then whatever is written in your E row, you're going to plug it into the K expression. Then you solve for the value of x using quadratic equation usually. And then, yan, once you have the value of x, if you have multiple values, ang gagawin mo is choose the x value that is positive o kaya kapag parehas yung positive, you choose the x value that has less amount or less value than the initial concentration. Okay? So, kailangan nyo mas onte. Because if you happen to subtract them, pwede maging negative yung equilibrium concentration mo, which is not acceptable. No? Because remember, there are no negative concentrations. Okay? So, yun lang. Okay? So, for now, I'm going to share to you the shortcut, no? Because there are times that you don't need to do the quadratic equation, no? Especially when you're quizzing. Bakit? Ang tagal kasi when you do quadratic equations. Lalo na if your calculator isn't capable of doing so. So, meron kaming shortcut na na-develop sa chem. Tawag dito ay small x approximation. Okay? So, in small x approximation, ganito yung steps natin. Okay? So, first things first, you check whether the reaction is strongly product or strongly reactant. So, when you say strongly product, the ratio of the concentration of reactant over K is greater than or equal to 1,000 pataas. No? So, alamin mo muna if pasok siya dito sa criteria na to. That the concentration of your reactant divided by K is greater than 1,000 or equal to 1,000. Kasi, if ang ratio nilang dalawa ay greater than 1,000, that means we can use the small x approximation. Okay? So, kapag ganun, pag ganyan yung ganap natin, we can use the small x approximation. Okay? So, paano yung small x approximation? Actually, ang magbabago lang ay yun nasa C row ng ice table. So, bigyan ko na nga kayo ng example. Kasi mga words na yan, madadaanan din naman natin pag nag-example na tayo. So, I will proceed na sa example para mas makita nyo yung application. Ha? Mahirap kasi sabihin lang yung words eh. Okay? So, anyway, kapag hindi pasok sa small x approximation yung inyong problem, then you have to do the quadratic equation as usual. Okay? So, try natin to if pwede yung small x approximation and what I am telling you about it. Ano ba yung pinapatukuyan ko, di ba? So, the first thing na gagawin nyo is ganito. For your equation or for your problem to qualify sa small x approximation, ganito gagawin natin. You divide the concentration of your acid with the K. Okay? So, yan. You divide the concentration of your acid with your Ka. And check natin if yan ay greater than 1,000 or equal to 1,000. So, the concentration of acid is 1.2. The Ka is 7.1 times 10 raised to negative 4. Divide natin yung dalawa. Okay, so if we divide that, that will be equal to 1690. Okay, so since our ratio of the acid and the equilibrium constant is 1690, that is greater than 1,000. So greater than 1,000 siya. So ibig sabihin, ano ibig sabihin nito? We can use small x approximation. Okay, so again, kapag ang ratio ng acid and the Ka is greater than 1,000 or equal to 1,000, we can use the small x approximation. Ibig sabihin, hindi na tayo magka-quadratic equation mamaya. Okay? So, ano yung meaning ng small x approximation? Ganito. Gawin natin yung ice table as usual. So, sulat mo yung mga species sa ice table. So, you have 1.2 for nitrous acid, 0 for the products. So, that means positive yung change for the product and then negative change for the reactant. Okay. And what's the equilibrium? 1.2 minus x, then x. Then, ano gagawin natin dito? Di ba, pina-plug in natin sa K. Okay, so, ipa-plug in ko na sa Ka. You already know how to do this. Okay, so di ba, babalik pa rin tayo dito sa process na to. Saan papasok yung small x approximation? Okay, so, papasok yung small x approximation dito sa concentration ng ating reactant. Okay, so dito siya papasok. Okay. So when we say small x approximation, we are assuming that the x value is negligible, okay, in the denominator, okay? So ibig sabihin nun, masyadong onti yung x that when you subtract it sa original concentration, it doesn't matter. Okay, so suppose that's 1.2 minus 0 point something. So you assume that your x value is less than 1.2, as in super onte kaysa dyan, no? So, ibig sabihin nun, kapag masyadong maliit yung x, we can virtually remove that, no? So, yun yung small x approximation. Ibig sabihin, pwede na natin tanggalin tong x na yan sa denominator. Yung sa numerator, hindi yan pwede tanggalin, ha? Okay. Only those that are written in the denominator. Yun yung small x approximation. Again, daanan uli natin. Ano nangyari? Diba, we have 1.2 minus x. Since this problem qualifies as small x approximation, we can tell na itong x na to ay negligible. Okay, so ibig sabihin pwede na siya burahin. Okay? So pag binura mo yan, you will be left with 1.2 na lang. Okay? Kasi qualified to sa small x approximation. Okay? So yan, so 1.2 na lang. So solving for x, that's easy. That's equal to the square root 1.2 times the Ka. Okay, so x is just the square root of 1.2 times Ka. You have your answer na agad, diba? So kunin mo lang yung square root ng 1.2 times the equilibrium constant. You have your concentration na 0.029, which is the same as what we solved last time. Okay, so yun yung small x approximation. Okay, so imagine yun, di tayo nag-quadratic equation, yet we were able to arrive with the same answer as our last attempt, di ba? So that's the small x approximation. Bakit tawag namin dito ay square root of Chaka? Okay. Okay. So ano ba yung 1.2? This is the concentration of the acid. So concentration of acid, we write that as CHA. Ayan, concentration of acid. Then yung Ka, the equilibrium constant. So to get the H plus concentration, you just get the square root of Chaka. Okay, so yun yung aming palatandaan para dyan. Okay, so whenever your problem qualifies sa small x approximation, just get the square root of Chaka. Okay, to get the equilibrium concentration of your H plus, and that will also correspond to nitrite ion concentration. Then yung HNO2, ipa-plug in mo dito yung X, no? So dito ka lang magbabago, not here sa table. Okay? So dito lang sa solving ikaw sa small x approximation, pero when you determine their equilibrium concentration, yung X dito magre-remain pa rin siya. Okay, so andyan pa rin siya. So at equilibrium, the concentrations are 1.171. This is 0.029, 0.029. Ito rin yung na-solve natin last time, di ba? Okay. So this time easier because we don't need to do quadratic equation. So again, when your problem qualifies to the small x approximation, you assume that the x in the denominator is negligible. That means pwede na siya burahin. So once you eliminate the minus x term here, all you have to do is to just get the square root of your concentration of acid and the Ka, or the square root of Chaka, to get the x value. Yan, tapos na. Tapos na yung problem. But yung square root of Chaka, mnemonic lang to. This is not always true, especially if you have coefficients dito. So, square root of Chaka will apply only if your coefficients are 1. Pero kapag yan ay may 2, 3, hindi nagagana yon square root of Chaka. Ibang level ng Chaka na yan. So, yan. So, yan. So, let's try some more problems so that we can appreciate this small x approximation. Malaking tulong to, no? Especially nung nag-boards ako. Kasi dati ginagawa ko quadratic equation talaga, no? Then sa review center, sinabi sa amin, square root of Chaka. Tumatak sa utak ko kasi Chaka eh. Di ba? Yan. Ang dali ko natapos sa subject na to. Okay. So, yan. So, let's try this. Calculate the equilibrium hydronium ion concentration from 2 times 10 raised to negative 4 molar of benzylamine. Okay, Ka is 2.5 times 10 raised to negative 5. Can we use the small x approximation dito? Tignan natin. Okay, so let's check if small x can be applied. Paano yun? You divide the concentration of your acid with the Ka and check mo if yan ay greater than or equal to 1,000. So what's the concentration of your acid? That's 2 times 10 raised to negative 4. Ka is 2.5 times 10 raised to negative 5. Minsan equal yan. Equal lang siya sa 8. So, ibig sabihin, this problem doesn't qualify sa small x approximation. Do not qualify sa small x. Ibig sabihin yan, magka-quadratic ka pa dito. Okay? Mag-quadratic ka dito. Okay? So, quadratic equation to, most likely. How about this problem here? Sasagutan natin to lahat. Check lang natin kung pwede gamitin yung square root of Chaka. Yun yung unahin natin. Okay. So, how about this problem? Okay, so we have 0.075 molar of ammonia. And the Kb, this is typo, Kb yan. Base to eh. So, the Kb is 1.75 times 10 raised to negative 5. No? Double check ko nga yung value. Ayan, tama. Kb yan. So, that's a typo. Kasi base yung ammonia. Okay, so let's check if we can use the small x approximation. So, hindi lang yung square root of Chaka nag-a-apply sa acids. No? Pwede rin siya sa base. No? Magbabago lang yung term natin. So, for base kasi, Cb lang tawag sa kanya, then Kb. So, Cb-Kb lang yung ganap niya. So, let's check kung ang kanilang ratio ay greater than or equal to 1,000. So, that will be 0.075 divided by 175 times 10 raised to negative 5. Sana pasok siya para makapag-solve tayo. Ayun, pasok siya. So, the ratio is equal to 4,285. So, this qualifies doon, ito qualified siya sa square root of Chaka. Pero since ito ay base, CB-KB na lang. Okay. So, kapag acid, square root of Chaka. Kapag base, CB-KB. Okay. Concentration of base times the equilibrium constant ng base. Ito, sagutan natin to kasi pwede natin to gamitan ng small x. Okay. So, gamitin natin small x approximation dito. So, on our ice table, write the species that are aqueous. So, we have NH3, NH4+, and OH-. Yung liquid, wag mo isasama. Okay, the initial concentrations, ang ammonia lang yung given. So, that will be 0.075, 0 for ammonium, and 0 for hydroxide ions. Then yung change, so since 0 sa product side, positive doon. And negative for the reactant side. Equilibrium, that will be 0.075 minus x. This is x and another x. Solving for x, we plug it into our equilibrium constant. So we have, wait lang. So we have x for NH4 and another x for the OH. So denominator, we have 0.075 minus x. And since this problem qualifies as small x approximation, ibig sabihin nun, we can omit this negative x part sa denominator. So, ganun ginagawa kapag qualified siya sa small x approximation. You delete whatever is written, you delete the x sa denominator. Okay? Kasi if hindi mo siya binura, magko-quadratic kayo. No? So, yan. So, we assume that the x is small, so we can neglect that. No? Burahin na natin siya para dumali ang buhay. Okay, so we assume that the x is small. Okay, and then we solve for the value of x. So that will be x squared equals 0.075 kb. Then x is equal to 0.075 kb square root. That's equal to 0.075 times the kb. So the x is 1.075 15 times 10 raised to negative 3 molar. So, yun na yung value ng X. Yun yung ipa-plug in natin dito. There's a question. Sir, paano po uli malalaman kung gagamitin yung small X approximation? Malalaman nyo kung gagamitin nyo yung small X approximation when you divide the concentration ng reactant by the K value. Kung yan ay greater than or equal to 1,000, dun ka mag-small x. Kaya di ba kanina dinivide natin ito at ito, we get 4,000. So since 4,000 yun, lagpas yun sa threshold natin, we can use the small x approximation. However, dito sa ginawa natin kanina, kinompare natin yung concentration and the Ka, that's 8 lang. So hindi pwede gamitin yung small x dito. Ibig sabihin, hindi mo buburahin yung x sa denominator ng K value natin. So, dito pwede kasi 4,000 to. So, binura natin yung minus x doon. Okay? So, ganun lang. Okay, so remember, you can use small x when the ratio of your reactant concentration and the K value is greater than or equal to 1,000. So, you divide them, yung reactant divided by the K. Pag dinivide mo yan, if that's greater than 1,000, small x tayo. That means you omit the x term in your denominator. Buburahin mo yung negative x doon. So, 0.075 na lang siya. Okay. What if hindi siya mag-qualify dito? What if less than 1,000 yan? Pag hindi siya mag-qualify, edi ano na, mag-quadratic ka na. So, hindi mo buburahin yung minus x dito. You solve this problem using quadratic equation. Okay, so ganun lang. Ano lang to, additional technique, no? Okay lang ba if kunwari, tanong nyo, okay lang po ba kahit di ko nagawin yung small x? Okay lang. Mas accurate nga yun. However, yung time yung gusto natin bawasan eh. Okay. Kasi kapag nag-quadratic equation kayo sa lahat ng problem, baka anong oras na kayo matapos sa quiz, no? And sa exam. Yung exam natin, puro problem solving yon. Yeah, wala tayong magagawa na. So, as much as possible, you try to apply all these techniques na sinishare ko sa inyo. Okay? Kasi malaking tulong yan. Pampabilis ng problem. Tignan nyo, sagutan natin to agad in less than 5 minutes. Pero nung nag-quadratic equation tayo, halos 10 minutes tayo. No? Okay? So, ganun lang. So, yan ha. Ito, I will leave this problem for you to answer because kailangan nyo mag-quadratic equation dito. Kayo na bahala magsagot dyan. Yung solution sa mga question dito sa PowerPoint, ipopost ko yung solution. And then, magdadagdag pa ako ng additional problems. No? So, ganun. We have at least 2 weeks before the, a week before the midterm exam. No? So, basta ganun lang ha. Pag qualified siya sa pag qualified siya sa small x approximation, please do it, no? Para hindi na kayo matagalan. Okay? So, let's proceed, no? Okay, so let's talk about percent ionization. So, percent ionization is a measure of the degree of ionization of your species, no? So, it tells us by how much na ionize yung ating reactants. Okay? So, that is the ratio of your concentration of acid at equilibrium and the initial concentration of your acid. No? So, you divide the two numbers to get the percent ionization. Okay? So, parang lang din to. Parang percent by volume. Okay? Pero this time, in terms of concentration. This tells you by how by what extent na ionize yung ating species. No? Kunwari, yung suka natin, yung acetic acid doon, ang kanyang percent ionization ay 5% lang, no? Okay? So, yun. Hanggang 5% lang siya. Then, for other acids, pwedeng greater than 5%, no? Less than 5%, no? So, parang that is just a measure by how much na-ionize yung reactants mo. Okay? So, ganun lang. Kasi remember, for strong acid, 100% yung ionization. For weak acids, the ionization is less than 100%. No? One example is yung suka. Yung suka natin sa bahay, 5% lang yun. Okay, so let's try this problem. Calculate the pH and the percent ionization of acetic acid. No? Wala akong nilagay na concentration pala. Manghula na lang ako ng concentration. Let's assume ito ay 0.5 molar acetic acid. Ayan. 0.5 na lang. Kalimutan ko i-type eh. Okay, so yan. Pag ganito yung problem, walang equation na binigay sa inyo, kayong gagawa ng equation. Dali lang naman. Okay. Paano? So since this is acid, you start with your reactant. And that is in aqueous phase, no? You react it with water. And they are in equilibrium to produce H3O plus and the conjugate base, no? The CH3COO minus. Okay, so again, paano gagawa ng equation? Pwedeng ganito. You have your acid plus water producing H3O plus the conjugate base. Again, the conjugate base is 1 hydrogen less than your acid. Yun yung relationship nila, di ba? Isang H lang yung nabawas. Saan mapupunta yung isang H? Kay water to, ayan, para maging H3O plus. Or, pwede rin naman ganito. Kayo bahala. So, pwede ganito na lang naman. Tanggalin mo na yung water. So, you will have your H plus. And then, you will have your conjugate base. So, yan. Pwede ganito, pwede ganyan. Up to you. But the most acceptable equation is the one written above, no? Okay. So, pero shortcut, ganito. Ito lang din ginagamit ko talaga. Although sabi nila mas acceptable to. Pero ito sa akin. Okay. So ganun ha. Kapag acid-base equilibrium yung H, babaklasin mo lang. Yun na yun. So yun nasa taas yung gagamitin natin. So let's write our chemical species in our ice table. We have the CH3COOH here. Then you have your H3O plus. Then you have your CH3COO minus. Tignan natin if this problem will qualify sa small x approximation. Okay? Check natin if this will qualify sa small x approximation. How? You divide the concentration of your reactant with your K value. Okay? So in our case, this is the concentration of your acid and the Ka value. So divide natin siya. Check natin if that's greater than or equal to 1,000. Okay, so what's the concentration of your acid? Sabi ko, 0.5. Ang Ka given na. So all we have to do is to divide them. Sana greater than 1,000 siya. Kasi kapag hindi, magka-quadratic pa tayo. Ayun, sakto. So the ratio of your concentration and the Ka is 27,000. Or 27,777. Okay. 27777. So, lagpas na lagpas sa 1,000. Yeah. Pag ganun yung ratio nila, matuwa kayo kasi hindi kayo magko-quadratic, ha? Okay. So, hindi na tayo magka-quadratic equation dito. Okay? You can use small x approx. Since the ratio is greater than 1,000. Okay? And take note nyo na lang yan. Okay, so since pwede tayo mag-small x approximation, continue ulit tayo sa ice table natin. So the initial concentration of the acid, the CH3COOH, acetic acid, is 0.5. Walang sinabi about the product, so 0 yan. For the change, positive sa product, negative sa reactant. This is 0.5 minus x, this is x and another x. Plug in natin yan sa Ka. So that will be the product's concentration. And so that's the concentration of H3O plus, CH3COO minus, divided by your acid. Okay, so the concentration of H3O plus is X. And then for the acetate ion, X. And then for the acid, that's 0.5 minus X now. However, ayan, so 0.5 minus X yan. However, since this problem qualifies as small x approximation, pwede natin burahin ito. No? So, small x approximation, we can just erase this part. Okay? So, yan. So, pwede na natin burahin yung nasa baba. Okay? So, let us now solve for the value of x. So, we have Ka x squared divided by 0.5. Solve for x. That will be x squared equals 0.5 Ka. X is equal to the square root of Chaka. 0.5 concentration of acid times your Ka. So, kunin ang square root ng Chaka. Okay, so that is 3 times 10 raised to negative 3 molar. So, yun na yung X value natin. So, let's plug it sa equilibrium. So, for the H3O, its equilibrium concentration is 3 times 10 raised to negative 3 molar. Same as for the acetate. And for the acetic acid, that is 0.5 minus 3 times 10 raised to negative 3. Saan equal yan? So that's equal to 0.497 molar. And so tapos na tayo sa problem. So ayan na yung kanilang concentrations, okay? Again, emphasize ko ulit for the last time. Check nyo if qualified yung problem sa small x approximation. Paano nyo malalaman? You divide the concentration of your acid or your base with the K value. So, i-divide mo sila, acid or base, divide mo yung concentration nila sa K value, Ka or Kb. Pag yan ay greater than 1,000, then you can simplify your quadratic, you can simplify this problem by eliminating the x in your denominator. Pwede mo na burahin yung minus x doon. Okay. So, once na binura mo na yung x doon, square root na lang yung operation mo. Okay. So, if that's the concentration of acid being determined, that's the formula is the square root of Chaka. Okay. When you want to determine the value of the concentration of acid, H3O or H+, square root of Chaka yon. Concentration of acid times the Ka. Chaka. Paano kapag base? Ayun, CbKb na yon. Concentration of base, tapos Kb, kunin mo square root nila. Okay, so ganun lang. Hopefully, tumatak sa inyo yung square root of Chaka. Kasi once na ma-recognize mo na yung problem na to, kahit di mo na isulat to. Kahit wag mo na isulat yan, basta alam mo square root of tsaka yun. Yun na yung x value mo. Ganun kasi ginagawa ko eh. Alright, pag dinivide ko dito is greater than 1,000, yung sagot ko agad kung ano yung square root of tsaka. Yun na yun. Okay? So, masasagot mo yung problem in less than 1 minute. No? Although, if you want to be very sure, you can write your solutions. No? Kasi mamaya, iba naman pala yung hinahanap. No? Mamaya, ito pala yung hinahanap. So, hindi lang siya yung square root of tsaka. Kasi isusubtract mo pa siya dito. So, yan. If you want to be very sure, you construct your ice table. Pero, if gamay nyo na yung problems, kahit i-mental nyo na lang yan. Okay. So, ganun. Let's try this. Calculate the Ka and the percent ionization of acid HA given that 0.7 molar of HA has a pH of 4. Paano to? Okay, madali lang. Okay. So, sulat natin muna yung reaction ng ng HA. Paano yung ionization ng HA? So, the ionization of HA acid, arbitrary acid yan. So, you react it with water, liquid, that will produce H3O plus and your conjugate base. Okay. So, ganito yung reaction parate pag nakakita kayo ng HA. Okay. So, kailangan medyo kabisado nyo na yung mga patterns. No? Nakasulat naman yun sa previous slides natin. Okay. So, if you're given an arbitrary acid, you write this equation. Sabi dyan, hanapin mo yung Ka. O, diba? So, ibig sabihin, trick question to. Hinahanap yung Ka. Tapos, the percent ionization of acid, given that ito yung original concentration niya and may pH yan na 4. Okay? So, paano natin malalaman yung Ka? Sulat mo muna yung equilibrium constant. So, looking at our problem, the equilibrium constant is H3O plus, A minus, and then you have your HA. Construct din natin yung ice table para mas makita natin clearly. So initially, you have 0.70 molar of your acid. 0 for your products. Then ano nangyari? At equilibrium, the pH is 4. So, ano meaning kapag equilibrium is pH equal to 4? Okay? So, kapag sinabing pH, that corresponds to the equilibrium H plus concentration eh. So, whatever your pH is, that corresponds to the equilibrium concentration of your H3O. Okay? So, dun yan nagko-correspond sa equilibrium concentration ng H3O. Okay? So, let's complete this ice table. So, 0 yung products natin. So, that will be positive X, and for the change, that's negative X. 0.7 minus X, X, and X. Since we know the pH is 4, that corresponds to the concentration of H3O at equilibrium. Okay? Take note, at equilibrium. Okay? So, the pH corresponds to the concentration of acid at equilibrium. So, since alam ko na yung concentration ng acid at equilibrium, I already know the value of X. Now, alam ko na yung value ng X. Saan equal yung X? Sa antilog ng pH. No? So, remember, pH is equals to negative log of H plus. So, ibig sabihin, you can determine the concentration of H plus at equilibrium by getting the antilog of the pH. Hindi yung 4 yung ilalagay mo dyan, the antilog, kasi naka-pH yan. So, to get the concentration of the acid at equilibrium, that's the negative log, the antilog of pH. That's 10 raised to negative pH. Or 10 raised to negative 4. O, yun na yung X value ko doon. So that means my X value here is 10 raised to negative 4. Yun na yung X. So that is also the concentration of my A minus. Since parehas lang silang X. So kung ito, 10 raised to negative 4, ang concentration nito, yun din yung concentration ng A minus. Kasi yun din yung X. X din siya eh. Pareha silang X. No? So, pareha sila ng concentration. So, yung HA ko at equilibrium, that will be 0.7 minus 10 to the negative 4. That is equal to 0.6999. Okay. So, yun na yung kanyang equilibrium concentration. Okay. Since I already know the equilibrium concentrations, I can now solve for the Ka. What's left for me to do is to plug in their equilibrium concentration. For H3O, that's 10 raised to negative 4. For A minus, that's 10 raised to negative 4. And then for HA, that is 0.7 minus 10 raised to negative 4. So, pwede ko na makuha yung Ka value. And that is equal to that's equal to 1.43 times 10 raised to negative 8. Ayun na yung Ka value ko. Di ba parang impossible siya sagutan, no? Pero possible naman. Okay, so again, paano natin nasagutan to? So, ganito. If you encounter problems like this, construct ka ng equation and then I-stable din. Gawa ka I-stable ng equation, pati ng Ka. Okay? Tapos, from the words dito, hanapin mo kung ano yung magbibigay ng clue about the equilibrium concentration. Usually, yung nagbibigay ng clue about the equilibrium concentration is the pH. Usually, ganun yung setup ng problem na to. Pag pinapahanap yung Ka, ibibigay yung pH o kaya pOH. Ganun yung usual na nangyayari. Remember that yung pH, that is the equilibrium H plus concentration. So, ibig sabihin kung may H plus ka dito, at equilibrium, ito na yung value niya. Yung antilog lang na itong pH. Okay? So, yun na yung kanyang equilibrium concentration. So, since you already know the value of X, you can substitute that to other X values here sa I-stable. Then, kung ano na yung resulting number, i-plug in mo na yun sa Ka. So, you will get the equilibrium constant. Okay, so again, for the last time, construct kayo ng equation ng I-stable pati ng Ka. Tapos, from the problem written here, hanapin nyo ano yung magbibigay ng idea about the equilibrium concentration. Usually, that is the pH, no? O kaya pOH. Yun lang yung mga nagbibigay ng idea usually. Okay? So, then, ano gagawin mo? By the way, hindi lang pala yung dalawang yun. Pwede rin yung percent ionization. Paano yun? No? Kunwari, sinabi, 10% ionized yung acid. Ionized the acid. Ibig sabihin nun, 10% ng initial concentration mo, yun yung X value. Okay. Kunwari, ganun. Sinabi, 10% ionized si acid. So that means your X value is the 10% of your initial concentration. Okay, so yun yung mga magbibigay ng clue kung ano yung value ng X. The pH, the pOH, and the percent ionization. Okay, so ganun lang. So once alam mo na yung X value from those three information, you can now plug those equilibrium amounts sa Ka. Pagka-plug in mo sa Ka, you have your answer na. Nakuha mo na yung Ka. Ngayon, how about the percent ionization naman? Hinahanap to sa problem na to. Hindi siya given, so hanapin natin. So for percent ionization, that's the equilibrium concentration of your acid, which is H+, divided by your initial concentration. No? So, ganun. Kapag percent ionization, yung concentration ng H+ yon divided by the initial concentration of your acid, HA. So, yan. Ito i-divide mo by this. This divided by that. Times 100%. So, that is 10 raised to negative 4 divided by 0.7 times 100. That's equal to 100. Ang percent ionization ay 0.014%. Ang baba ng ionization. So, only 0.014% ang na-ionize. No? Okay, so ganun. So again, paano nyo malalaman yung equilibrium concentrations kapag given yung pH, pOH, o kaya pag given yung percent ionization? Gagawin mo lang, i-divide mo yung initial, i-multiply mo yung initial dito sa percent mo to get the equilibrium value ng iyong products. Okay. Doon mo malalaman yung X. So don't worry, magbibigay pa akong mga worksheet na maraming ganito para mag-practice kayo. Okay, so yan. So more problems about the calculation will be given sa additional worksheets natin. Okay, so yan. So now let's go here naman. Let's talk about the ionization constant of conjugate acid-base pair na. So suppose we have this equilibrium expression for the acid dissociation. So yung acid natin HA that will dissociate into H+ and A-. Okay? And yung ating conjugate base ng acid natin ay ito naman. So that will react with water to produce hydroxide and HA. No? So itong dalawang equation na to nakasulat na to sa mga previous slides natin. So tinitignan natin dito yung relationship ng acid and our conjugate base. No? Okay, so tinitignan natin yung relationship ng dalawang equation. If we combine the two equations, magka-cancel out yung A- pati yung HA natin. So basically, when you combine the reaction of your acid and your conjugate base, you will get the ionization of water alone. No? So again, when you combine the acid equation with the conjugate base equation, you will get the ionization equation for water, which is equal to Kw. So that means Kw is equal to the product of the two Kas. Pag pinag-combine yung dalawang equation, we multiply the two K values. So that means Kw is equal to Ka times Kb. So, kunwari, given ka ng Ka, hinahanap mo yung Kb, or you can use this equation to solve for the Kb. So, Kb is equal to Kw divided by Ka. Kunwari, hinahanap mo yung Ka given yung Kb, that's Kw divided by Kb. Okay? So, may mga ganung problems. Kunwari, ang given, Kb, pero ang kailangan mo, Ka, you use this equation. Saan ulit ito nakuha? Sa pag-combine ng conjugate acid-base equations. You have the acid, you have the conjugate base. Pag pinag-combine mo yung dalawang equation, you will just get the ionization equation for water. So that means Kw is the product of Ka and Kb. So yun lang. Additional info lang yan. So ngayon naman, let's proceed sa next one. So diprotic and triprotic acid. No? As you can see kanina, yung ating mga molecules ay isa lang yung H niya. No? How about those acids that have more than one H? No? Kapag mas marami pa yung H niya. Nari, H2SO4, H3PO4. Ano? How about them? Kapag dalawa o tatlo na yung H nila. We call those molecules with more than one H as the diprotic or the triprotic acids. So diprotic and triprotic acids yield more than one hydrogen ion per molecule. For example, H2SO4. Ano yung dami ng H plus na mapoproduce niya? Dalawa. H3PO4. Gano'ng karaming H plus mapoproduce niya? Tatlo. Okay? So, however, the ionization of your hydronium ion is stepwise ang manner niya. So, that means the H is being dissociated one at a time, no? So, yung isang H muna mababaklas, then the other H will follow. So, stepwise yung process. They lose one proton at a time. So that means since multiple yung ating dissociation, we can write multiple ionization constants for each stages. No? Okay, so that means we have to employ the use of the ice table more than once. No? Para makuha yung final answer talaga. Okay, so suppose we have this carbonic acid. Carbonic acid will dissociate first into hydronium ion and bicarbonate anion. Okay, so ito yung first ionization niya. Then the other ionization is yung H uli, no, ng bicarbonate. Yun yung matatanggal. So our bicarbonate will further dissociate into H plus and carbonate ion so that we produce 2 H plus ions. No? Dalawa na yung na-produce nating H plus. So, clearly, magkaiba sila ng Ka values, no? So, if you want to determine the concentration of each species, then you have to do the ice table for this one and this one. Okay, so don't worry. Hindi na natin muna yan i-discuss in depth ngayon. Basta ang idea lang is that if you have diprotic or triprotic acid, those are acids with more than one H, no? Dalawa o tatlo yung H nila, then you have to employ multiple ionization equations. No? Multiple ionization equations. Bakit? The removal of H plus is stepwise. Isa-isa yan. Okay? So that means for every stages ng pagtanggal ng H, may corresponding K values yan. So kung gusto mo alamin yung concentration nila, multiple times mo yan isosolve, no? Dalawang beses ka mag-ice table dito. So hindi muna ako magbibigay ng ganyan, no? So sagutan natin yung mga ganyang problems pagdating sa titration, which is next chapter after the midterms. So here are some of the K values of our acids na diprotic, triprotic, no? So, ito yung kanilang K value. Remember that sulfuric acid, this is a diprotic acid. The first dissociation is very large. So, that means kung ano yung concentration ng sulfuric acid mo, after the dissociation, yung concentration na yun ay equal sa H plus concentration and the HSO4 concentration. Then, kung ano yung HSO4 concentration, Yun yung gagawan mo ng ice table sa susunod. Don't worry, magbibigay kami ng ganyang problems pagdating natin sa titration. Chill lang muna kayo. Idea lang muna gusto natin dito, ha? Okay. So, the idea lang is that multiple stages ng ice table gagawin nyo if necessary. However, for sulfuric acid, the first stage is strong reaction kasi yan. Strong acid kasi yung first reaction. Kaya, stoichiometry lang dyan. Dito ka lang mag-ice table sa second stage. For the others, you have to do the ice table in every stages. No? For example, phosphoric acid, tatlong beses ka mag-ice table dyan. So, good luck. No? Good luck sa atin next chapter. So, yan lang idea ha. Again, if you have more than one H+, you have diprotic or triprotic acid. The ionization is stepwise. Isa-isa lang yung pagbaklas ng H. No? And since stepwise yan, you have multiple stages. It corresponds to different K values then. No? If you want to determine the equilibrium concentrations, then you have to do multiple ice table calculations. Okay. So this will be discussed in depth when we go to titrations of acids and bases. Next chapter. After the midterms naman yun. Okay. So now let's talk about buffers. No? Okay. So we know, I don't know if alam nyo na, no? Buffers solutions are solutions in which they resist the pH change. No? So ito yung mga solution na hindi agad nagbabago yung pH. No? So, sa katawan natin, maraming ganito. No? Our body is composed of different buffer systems. Bakit? Suppose wala tayong buffer system. Uminom tayo ng soft drinks. Ano yung acidity agad ng katawan natin? pH 2. Kasi pH 2 yung yung mga soft drinks eh. Imagine nyo if ganun mangyari sa katawan natin. Biglang nag-pH 2 yung katawan natin. What will happen? We will die agad, no? Because at pH 2, our cells will deteriorate, no? They will be denaturized, no? So imagine nyo if katawan natin walang buffer system, matagal na tayong deads, no? Kasi kapag huminga tayo ng I mean, kapag uminom tayo ng soft drinks, sobrang acidic na natin agad nun, patay agad yung cells natin. Okay? So, kunwari, uminom ka ng basic compound, let's say Kremil S. Sira na rin yung cells mo pag ganun. But the reality is hindi, no? So, our body is designed to handle different pH values of what we take in, no? Uminom ka ng suka, hindi ka naman namamatay, di ba? Bakit? Kasi our body is composed of many buffer systems. The buffer systems maintain the pH of our body. They try to control the pH, no? Kahit ano pa ilagay mo dyan. Okay? So, yan. So, what is a buffer system ba? A buffer system is a mixture of the acid and its conjugate base, no? So, ganun sa katawan natin, may mga acid and their conjugate base, no? So, one example will be the carbonate buffer sa ating blood. So, our blood consists of carbonic acid and bicarbonates, no? So, the balance of bicarbonates and carbonic acid makes our blood stable, no? Kasi buffer system siya. So, another example would be on our cells, no? Yung cell natin, they are comprised of the phosphate buffers. Okay? May biphosphate and mayroong phosphate ions. So, nakabalance yung ions na yon so that the pH of the cell is constant, no? Okay? So, ganun. So, again, what is a buffer system? A buffer is a solution that resists the changes in the pH. And it is composed of your acid and the conjugate base. Okay, so yan. So suppose we have a mixture of an acid and its conjugate base in salt form, naka-salt form lang, Na. So, what will be the reaction of our conjugate base and the acid now? So, ito yung ating salt na may conjugate base. So, you have this salt of your conjugate base. It will dissociate into the cation and the conjugate base ion. Yung HA naman natin, yung weak acid natin, it will dissociate as H plus and A minus. Okay? So, remember that for this equation here, Ka is written as this now. So, solving for H plus, rewrite mo lang yan. So, we rewrite this equation to get the H plus, and then we obtain the negative log of both sides. So, we get the negative log of both sides. We will arrive with this equation. So, maghihiwalay yung products. Okay? So, maghihiwalay yung Ka pati HA. Okay? So, kaya nag-split sila into 2. According yan sa law ng logarithm. But we will not dive into that. No? Okay, so basta maghihiwalay sila when you take the negative log. And we know that negative log H is pH. Okay? And the negative log of Ka is the pKa, minus the log of HA over A minus. Okay. So this equation we have here is the Henderson-Hasselbach equation. And this equation will tell us kung ano yung ratio ng acid and the conjugate base, no? Ano yung correct concentrations to maintain the buffer pH, no? So yun. So pinapakita dito yung ratio ng kanilang amounts para ma-maintain yung buffer. So that is pH equals pKa minus log of the acid divided by the conjugate base. Okay, so that's the Henderson-Hasselbach. Again, ano yung ginagawa nito? This tells us the correct ratio of acid and conjugate base. Okay? So, yan. May double check lang ako, ha? Wait lang po, may double check lang ako. Kasi parang may something wrong about the equation. Okay. Okay, so this is the Henderson-Hasselbach equation. Tama naman pala yung correction. Ano lang yung parang na-notice ko. For other reference kasi, ganito yung nakalagay, no? Ang nakalagay is ganito. Sa ibang book. For other references, this is the form of the Henderson-Hasselbach equation. Baka isipin nyo magkaiba yan kasi ako nga napaisip pa rin ako. Feeling ko magkaiba sila, no? But remember, according to the law of logarithm, when you flip the equation or when you get the reciprocal of the equation, magfi-flip din yung sign ng log, no? So kapag binaliktad mo tong HA pati A, itong negative magiging positive, no? So this is another form of the Henderson-Hasselbach equation. So you can use any of the two. Same lang yan mathematically. Again, so ang takeaway natin dito is that this will tell us the correct ratio of acid and the conjugate base to maintain the pH of our solution. So kuha tayong isang problem. What is the pH of a solution containing 0.03 molar of formic acid? Formic acid to. And 0.52 molar of potassium formate. Okay. So, given yung concentration ng ating acid and yung concentration ng ating conjugate base, no? Pwede na natin malaman yung pH ng solution na yan. Okay? So again, kapag buffer system, ibibigay sa inyo yung concentration ng acid and the concentration of the conjugate base, no? So once you have the two mixture, acid and the conjugate base in salt form, meaning ng salt may cation siya, either potassium, sodium, no? So yan, in salt form. Once you have those two mixtures, then that means the problem is about buffers now. For you to solve for the pH, madali lang yan. So that's pH equals pKa plus logarithm ng concentration ng conjugate base over the acid. Ano yung concentration ng conjugate base? Ayun, no, 0.52 molar. So ipa-plug in mo na lang. What is the concentration of the acid? 0.3 molar. Okay. How about the pKa? No? The pKa, remember, that's the negative log of your Ka value. So, may pKa na ba tayo for our formic acid, the HCOOH? Meron na. Nasa table last time. So, gagawin mo, titingin tayo sa table kung ano yung pKa niya. Okay, so dito. So, you look at the table kung ano yung Ka value niya. So, this is our formic acid. The Ka is 1.7 times 10 raised to negative 4. Okay. So, 1.7 times 10 raised to negative 4. Paki-plug in yun dito. So, that's negative log of 1.7 times 10 raised to negative 4. The pKa value is equal to it's equal to 3.77. So again, yung pKa, makukuha mo yan sa negative log ng Ka. Pag hindi binigay yung Ka, hanapin nyo sa table. Okay, may table naman last time, no? So dun yung hanapin yung Ka. So what will be the resulting pH of our solution? So that's pKa plus log of the concentration of your conjugate base and your acid. So the pH is equal to 4. So if you want to maintain a solution whose pH is equal to 4, then you have to have this ratio of your acid and the salt. Kailangan yan yung ratio nila. The pH will be equal to 4. So saan to ginagamit? No? Ang ginagamit yung buffers sa pag-calibrate ng pH meter. So ang ginagawa namin doon, we will determine the amounts of my acid and the conjugate base. Tapos paghahaluin lang namin sila, we have the buffer solution na agad. Instantly yon, no? Okay, that's governed by the Henderson Hasselbach equation. As long as you have the correct amounts of your acid and the conjugate base, that will give you the exact pH you need, no? So sa thesis, ginagamit to, especially when you're cultivating enzymes, no? If you're cultivating bacteria, enzymes, no, you want to maintain certain pH, that means you need to create buffer solutions pa. Okay? So, ganun lang ka-easy yung solving niya. Okay? So again, a buffer solution, it has the ability to resist the changes in pH when you add acids or bases. No? And it contains both weak acid and the salt of the weak acid. Or pwede rin namang weak base siya and the salt of the weak base. Okay? So, ganun lang. So, kung i-graph natin yung changes ng pH when we add other species, no? Kunwari, naglagay tayo ng additional acid. If we graph their concentrations or the pH, tignan nyo. Kapag water lang, naglagay ka ng acid, drastic yung change sa pH. Pero, if you have buffer solution, tas nagdagdag ka ng acid, hindi magbabago yung pH. Virtually, no change ang pH mo when you have a buffer solution. So, ito yung gusto ng katawan natin, no? That regardless kung ilang litrong suka inumin mo, the pH of the body will never change, no? Hihilab lang yung tiyan mo. Okay? So, kaya ganun. So, yun. So, again, buffer solutions, they help resist the changes in the pH, no? Regardless if you add acids or base in your solution. They will try to maintain the balance, no? So, let's try to, check kung sino sa tatlong to ang buffer systems. Okay? So, let's try to check kung sino dito ang buffer systems. Okay, so we have letter A, we have KF and HF. Is this a buffer system? Okay, ganito. Identify mo yung acid. The acid is HF. Okay? HF is the acid. So, ano meron sa KF? Yung sa KF mo, since ionic compound yan, you dissociate that into two. Gawin mo siyang K plus ion and F minus. Okay? So, obviously, yung K plus, wala yung kinalaman. Cation lang yan on salt, no? How about the F minus? Is this related to your HF? Related ba siya sa HF? Ang sagot ay yes, no? Bakit? F minus or the fluoride ion is the conjugate base of hydrofluoric acid, no? HF. Paano mo malalaman kung conjugate base conjugate base sila ng acid? Nabawasan lang sila ng isang H, no? So yung HF, bawasan mo ng isang H, maging F na lang yan. Okay? So since you have the acid, HF, and you have the conjugate base in your salt, KF, these two are buffer systems. No? Buffer yan. Bakit? You have the acid, HF, and then you have the salt containing the conjugate base. No? So yung KF, it contains the F minus, no? Which is the conjugate base of your acid. So that means this solution, this mixture is a buffer system. And yun, it can maintain certain pH. No? About letter B. For letter B, identify the acid. Usually, yung HBr yan. Ito yung acid mo. Then, dito sa KBr, ano meron dyan sa KBr natin? So, sa ating KBr, meron tayong potassium ion and bromide ion, di ba? So, you have K plus and the Br minus. So, yung cation, wala tayong pake dyan. So, pansinin natin yung anion. Is this related to HBr? Ang sagot dyan ay yes, it is also related to HBr. Okay? So, since it is related to HBr, that means ito ay yung conjugate base ng HBr. No? So, ito yung conjugate base ng HBr. So, since we have the acid and the conjugate base, that means we have buffer solution. Meron na tayong buffer mixture. So, meron tayong buffer dito. So, again, if you want to check kung yan ay buffer o hindi, just determine kung meron kang conjugate base and the acid. No? Tignan mo lang, may conjugate base ka or may conjugate acid ka. Ano yung difference nila? Yung isa, walang H. Yung isa merong H. Okay? So, ganun. Yun lang. So, ito ay buffer din. How about letter C? Ito sa letter C, medyo hindi siya obvious. Okay? So, gawin natin. For letter C, medyo hindi siya obvious. So, you have Na2CO3 and you have NaHCO3. Ito ba ay buffer? Alamin natin. So, gagawin natin yung Na mo, yung mga cation mo other than the H, burahin natin. Okay? So, tanggalin natin yung Na. So, anong ions mapuproduce natin dito? You will have Na plus and then you will have CO3 minus 2. You have your carbonate ion here. Itong sodium bicarbonate naman, you will have your Na plus and then you have your HCO3 minus. And as I told you kanina, yung Na, yung mga metals natin, wag mo sila pansinin. Wala naman silang role. So let's compare kung ano yung natira sa atin. You have HCO3 and you have CO3. Are these two related? Yes, they are related. Bakit? Paano sila naging related, sir? Tignan nyo yung ano lang difference nila. Yung HCO3, may isang H, ito walang H. So that means they differ sa isang H lang. Kapag they differ with one H, that means yung isa dyan ay acid, yung isa conjugate base. Kapag isang H lang yung difference nila, meaning yung isa ay acid, yung isa ay base, conjugate base. So, sino sa dalawa yung acid? Eh di yung may H, no? So, ito yung ating acid and ito yung ating conjugate base. Okay, so again, ang basis natin is kung isa lang yung difference nila sa hydrogen. So, since isa lang yung difference nila sa hydrogen, that means ito yung acid, yung may H, yung nabawasan or yung wala, yun yung conjugate base natin. So, since we have the mixture of the acid and the conjugate base, that means we have a buffer solution. So, may buffer solution tayo ng carbonate and bicarbonate ions. Okay, so that's how we tell, no? Kung meron tayong buffer system. Magdadagdag ako, letter D. So, I will add another item dito. How about this? How about letter D? You have phosphoric acid, H3PO4, and potassium phosphate. Do you have a buffer system when you mix the two? Okay, so anong gagawin mo dyan? Malamang, yung H3PO4, ito yung acid mo. Itong salt mo, paghiwalayin mo siya into K plus and phosphate ion. Yung K plus, yung mga metal, huwag papansinin. Pansinin yung anion. Is this related to H3PO4? Yes, pareha sila may phosphate, pero hindi sila related actually. Pareha sila may PO4, pero hindi sila related. Bakit? Kasi, ang tinitignan natin ay yung isa lang yung difference nila sa H, no? Kung ito H3PO4, tas ito H2PO4, buffer yon. Pero in our case, this is H3PO4, this is PO4. Ilang H yung difference nila? Tatlo. So, since tatlo yung difference nila sa H, hindi yan buffer system. Ano ba yung difference sa H kapag buffer system? Isang H lang yung pagitan nila. Okay? For example, ito pati ito, isang H lang difference nila, buffer yon. Itong Br minus pati HBr, buffer system yan. Kasi isang H lang difference nila. Itong F minus, itong HF, buffer yan. Kasi isang H lang pagitan nila. However, for our item letter D, they are not related talaga. No? Kasi tatlong H yung pagitan nila. So since 3H yung difference nila, hindi siya qualified as buffer. No, this is not a buffer mixture. Or hindi siya buffer solution. Again, paano mo malalaman kung buffer yan? Isang H lang yung difference ng ating ions. Okay, so let's cap this problem by answering this type of question. Okay, so ito na lang. Additional na lang to. Although, onti lang na ganito ibibigay ko sa quiz. No? Okay, so calculate the pH of the 0.3 molar ammonia, 0.36 molar ammonium chloride buffer system. Which is the pH after the addition of 20 ml of 0.05 molar sodium hydroxide to 80 ml of the buffer solution. Okay? So, paano to? Sagutan muna natin yung first sentence. Ang first sentence, sabi dyan, hanapin ang pH ng 0.3 molar ammonia and 0.36 molar ammonium chloride solution. So, hanapin daw muna natin yung kanilang pH. Paano natin alamin yung pH niyan? So, we can use the Henderson-Hasselbach equation. So, that is pH equals pKa plus logarithm of the conjugate base over the acid. Okay, so yan. So yan yung ating yan yung ating tawag dito. Yan yung ating Henderson-Hasselbach equation. Ano yung given sa atin? We are given ammonia and ammonium chloride, no? So is ammonia an acid or a base, no? Alamin natin, yan ba ay acid or yan ba ay base? Ammonia is a base. So, ibig sabihin, hindi natin pwede gamitin tong Henderson-Hasselbach. Bakit? Tignan nyo. Nakalagay dito acid, conjugate, base. Ang meron tayo, we have a base, and then we have a conjugate acid. So, paano yon kapag ganun? Ang ating Henderson-Hasselbach equation ay in terms of acid kasi you have acid, conjugate, base. Ang meron tayo, ammonia is a base, and we have the conjugate acid of the base. No? So, paano yon? Ganito lang. You will rewrite your Henderson-Hasselbach equation. I-rewrite mo lang siya. Okay? So, paano yung isang version ng Henderson-Hasselbach equation? So, the version of the Henderson-Hasselbach equation ay yung counterpart. No? So, ano yung counterpart ng pH? Yan ay POH. Ano yung counterpart ng pKa? Ayan yung pKb. Okay, so yan yung pKb, the negative log of Kb. How about yung counterpart ng conjugate base? Conjugate acid, no? So, conjugate acid is written as BH. Conjugate acid yan. And how about yung counterpart ng acid? E di yung base, no? So, ito yung counterpart ng Henderson-Hasselbach kapag base yung equation. Pakinote na lang, dalawa yung forms ng ating Henderson-Hasselbach. One is the acidic form, the other is the basic form. If you have acid, you will use this. If you have base, you will use this. No? Hindi mo pwede gamitin ito for the base eh. Kasi wala naman ditong base na nakalagay oh. Acid lang meron. Conjugate base meron. Pero hindi yung base, no? So, ito yung counterpart ng ating Henderson-Hasselbach kapag base ang ating species. What's next? No? So, that means we will need to use this equation here. So, gamitin natin yung equation na iyan. Burahin ko muna itong ano natin. So, our equation now is POH equals PKB plus log ng conjugate acid over the base. No? Note natin, conjugate acid and the base. So, alamin muna natin yung pOH nila. Alamin ang pOH. So, paano yon? Alamin mo yung pKb ng ammonia. Ano yung pKb ng ammonia? Hindi natin kabisado, tumingin sa table. So, tignan natin yung base dissociation constant. Nandun nakalista yung Kb. Yan, so ito yung Kb ng mga bases natin. So, we have the ammonia. Ito yung base natin. Yung kanyang Kb ay equal sa 1.8 times 10 raised to negative 5. So, kunin natin yung 1 times 10 raised to negative 5. So, to get pKb, that's negative log of Kb. 1.8. Kunin natin yung negative log ng 1.8 times 10 raised to negative 5. So, ano yung pKb natin dito? Negative log 1.8 times 10 raised to negative 5. So, ang pKb ay 4.74. Yan yung pKb. Plus log ng ating conjugate acid. Ano yung concentration ng conjugate acid ng ammonium? 0.36. Ano yung concentration ng base natin? 0.3, yung ammonia. So, ipag-divide natin yan, we will get pOH equal to 4.74 plus log. So, the pOH is equal to 4.82. Ang tanong, pH. Alamin yung pH. So, that's 14 minus 4.82 lang. So, the pH of the solution is 9.18. Okay? So, that means when you mix 0.3 molar ammonia and 0.36 molar of ammonium chloride, you will get the pH of the solution equal to 9.18. Okay? So, we use the other version of the Henderson-Hasselbach equation since yung previous equation natin kanina ay naka-acid yun eh. Naka-pH yun eh. In our case, base yung meron tayo. So, we have to get the counterpart of this Henderson-Hasselbach equation. That's why ganito yung ginawa natin dito. You can get the pH naman once you know the pOH. No? So, ipa-plug in mo lang ito. Then you will get this. Let's talk about the second part of the question. Tignan natin yung nangyari sa second part ng equation. Ano nangyari? For the second part of our equation, ang nangyari is, naglagay tayo ng 20 ml of 0.5 molar sodium hydroxide. No? So, naglagay tayo ng 20 ml of 0.5 molar sodium hydroxide to 80 ml of the buffer solution. Okay? So, what will happen when you add base? Ano mangyayari kapag nagdagdag ka ng base ng sodium hydroxide? Ibig sabihin nun, tataas yung amounts ng base, bababa yung amount ng conjugate acid, no? Kasi nagdagdag ka ng base, sodium hydroxide. So, ibig sabihin, tataas yung amount ng base, mababawasan yung conjugate acid. What if nag-add ka ng acid? If you add acid, tataas yung conjugate acid, bababa yung base. Okay? So, since we added base, no, sodium hydroxide is a base, madadagdagan yung base natin, mababawasan yung acid natin. So, pag ganyan yung case, no, kopyahin nyo lang tong ating equation kanina. Okay? So, since madadagdagan yung acid natin, ay yung base natin madadagdagan dahil sa addition ng sodium hydroxide. Magpa-plus tayo dito sa baba. Kasi madadagdagan yung base eh. So, madadagdagan yung base, so plus dito. Yung acid, ito mababawasan to. So magma-minus tayo dito. The question is, ano yung i-add ko? Ano yung isusubtract ko? Yung amount ng dinagdag kong base. Okay? So, since naka-molarity itong dalawa, dapat molarity din yung expression ko dito. Okay? So, kailangan molarity din yung ilalagay ko dito. Paano yon? Ganito. If you have 20 ml of 0.05 molar ng sodium hydroxide, kunin mo yung moles ng NaO. Kunin mo yung moles ng sodium hydroxide. Paano yon? Diba, molarity times the volume is equal to moles, diba? So, get mo muna yung moles ng sodium hydroxide. So, ano yung mole ng base na dinagdag mo? So, that's 20 ml times 0.05 molar. That's equal to 1 millimole. Diba? Again, ml times molarity, millimole. Okay? So, again, kunin mo muna yung millimoles ng base mo. Multiply molarity and the volume ng sodium hydroxide. No? You get the millimoles of your base. Then you divide it by the volume of the solution. Okay? Kasi magbabago yung molarity niyan, no? Pag nilagay mo yan sa solution. 80 ml yung solution eh. Okay? Tsaka lang. So we have 1 millimole of your base na. Ngayon, ano yung magiging molarity niyan when I add it sa solution ko? Ano mangyayari when I add it sa solution ko? Gawa tayo dito ng site ng space. Okay. So yung 1 millimole ng base, i-add ko yan sa solution. Magbabago yung volume nun. Bakit? Kasi I initially have 80 ml of the solution, then naglagay ako ng 20 ml. So magiging ang total volume ng solution ko ay 100 ml, no? Okay? So magiging 100 ml yung entire solution ko. So I will divide 1 millimole of your base by the total volume of your solution. So you will add 20 plus 80 ml. Kasi magbabago na yung volume ng solution ko. Okay? So that will be 1 millimole divided by 100 ml. So I will get 0.01 molar ng base, no? So 0.01 molar ng base yung nadagdag ko sa solution in total. So yun, itong 0.01 ko, yun yung ipa-plug in ko dito, no? So yan, 0.01 here and 0.01 there. Then I can now solve for the POH, no? 0.36 minus 0.01, 0.3 plus 0.01. So, anong nangyari yung POH ko? So, from 4.82 naging 4.79 na. And the corresponding pH ay tumaas, no? Naging 9.21. Okay? So, ganun yung calculation dito. So, again, ano nangyari? Ang nangyari, itong first sentence, ito yung solution natin dito. So, second sentence, ang ginawa natin, nag-add tayo ng additional base. So, ibig sabihin yung concentration ng base natin tataas, yung concentration ng conjugate acid bababa. By how much? Ganito gagawin nyo kapag gusto nyo alamin gano'ng kalaki yung idadagdag niya or ibabawas. You get the moles of your base added and you divide it sa total volume ng solution. So initially you have 80 moles, 80 ml of the solution. Since nagdagdag ka ng 20 ml ng base, so since nagdagdag ka ng 20 ml ng base, so all in all, 100 ml na yung solution mo. Diba? So, you divide the moles of your base by the volume of that solution in total na, you get the molarity na ng dinagdag mo. Yung molarity na yon, yun yung ipa-plug in mo sa inyong logarithm. So, minus for the conjugate acid and plus for the conjugate base, for the base. No? Kasi base yung dinagdag mo. So, magpa-plus ka sa baba. Magma-minus ka sa taas. And as you can see, yung ating pH tumaas, no? But hindi ganun kalaki yung pagtaas niya. Not that much yung increase. Kasi sabi nga natin, buffer systems, they try to minimize the effect of addition ng bases, no? So, onti lang yung magiging difference sa pH, no? Despite na ang dami mong nilagay na base. Okay? So, anyway, siguro kikita nyo parang ang hirap naman yan, no? Okay, so mahirap talaga medyo yung buffer systems, no? That's why onti lang na ganito yung ibibigay ko. Mostly ganitong style lang sa left yung ibibigay ko. Kasi itong ginawa natin dito sa right side, ito ay covered na sa titration, no? Nasa titration kasi ito eh. Kaya ganun. Kaya parang feeling natin complicated na. Di-discuss pa natin to sa titration, don't worry. Pero ito nasa left side, mostly ito lang yung ilalagay ko sa quiz natin, ha? Itong nasa right side, ano na yan? Preview na yan sa gagawin natin next chapter. Parang complicated na, no? Yes, no? Pero ganyan talaga yung steps done. Okay? So again, sa quiz natin, most likely, ito lang yung papasolve ko. Yung calculate the pH of the mixture. Pero kapag nag-add na sa next chapter na yon, sa titration na yon. Ayan. So binigyan ko lang talaga kayo ng preview. Okay? So, ito yung isang example ng buffer system sa ating body, especially sa blood, no? So, our blood tries to maintain the balance. The pH of the blood is around 7.4, no? Because of the phosphate buffer there and the carbonate buffer, okay? So, bakit kailangan i-maintain yung pH ng blood, no? Kasi at different pH, our blood may be destroyed, no? Ang blood natin ay protein. Ang protein, they can be denatured at different pH, no? Try mo lagyan ng suka yung egg white. Masisira 'yun, 'di ba? Okay. Kasi ganun ka-delicate yung ating proteins, no? If you just change the acidity of your solution, then your protein molecules will be distorted, no? Masisira sila, destroyed sila. So that's why our blood has to maintain buffers, no? So that when you add other species to your blood, no? Kunwari nagdagdag ka ng suka, no? Uminom ka ng suka, onti lang yung magiging change sa pH, no? Kasi imagine if your body doesn't have any buffer system, matagal na tayong deads, no? Huminga lang tayo, patay na tayo. Kasi malaking change 'yon sa concentration ng acidity, no? Sa ating katawan. Yan, kaya yan. So thankful pa rin tayo kay buffers kahit medyo mahirap yung approach niya, no? Ganun talaga. Okay, so anyway, so for the quiz, no, ang i-cover ko lang ay yung Henderson Hasselbach calculation. Yung addition ng other species, sa ano ko na yan ibibigay sa next chapter na. Although maglalagay ako sa worksheet, ha, para ma-practice kayo. Okay, so by Monday, ito tapos na tayo. By Monday, we will discuss solubility equilibria. Mabilis lang to, onting slides lang to eh. And the common ion effect. Okay, so I'll see you again on Monday. If you have any questions, don't hesitate to ask me lang. Ayan. Again, ito yung mga pointers na kailangan ninyo tandaan today, ha? Mag-recap tayo. Ano yung mga kailangan nyo tandaan today? Yung small x approximation. Kailan mag-small x approximation? If the concentration and the K greater than 1,000 yung ratio nila. Okay, that will help you to reduce the use of quadratic equation. Percent ionization, that is the ratio of the H plus with your initial acid, no? So, kunin mo lang yung ratio nila times 100. The percent ionization for weak acid is less than 100%. Okay, less than that. Kasi weak acid niya eh. And then, yung relationship ng Ka and Kb, it is written as this, no? So, kunwari, Kb binigay sa inyo, pinapahanap Ka, then you have to use this equation. Their product is equal to Kw. For acids with multiple H, tawag natin doon ay diprotic and triprotic acid. The dissociation of H is stepwise, no? So, ibig sabihin, isa-isa lang yung pagbaklas ng H. And for each dissociation of H, may corresponding K value yon. So that means this will need more the use of I-stable multiple times, no? So next chapter na yan kasi mas complicated yan. So in this table, we have the ionization constants of different diprotic and triprotic acids. Buffers, these are mixtures of weak acid and its salt, o kaya weak base and its salt. No? So we have a mixture of those ions and they resist the pH changes, no? The drastic pH change. If you want to determine the correct proportion of your salt and your acid, o kaya your salt and your base, you have to use the Henderson-Hasselbach equation. Ano yung mga other versions niyan? So the other version is positive itong logarithm. Since positive yan, mag-flip yung ating ratio doon. So mag-flip siya, magre-reciprocate siya. The other version of the Henderson-Hasselbach equation ay kapag base yung iyong species. Kapag base ang iyong species, you will need to use this. No? So again, BH plus, this refers to the conjugate acid. B, this refers to the base. A minus, conjugate acid. Conjugate base pala. And the HA is the acid. Okay. So basta alam mo yung amount ng conjugate base, conjugate acid, pwede mo malaman yung pH. No? What if gusto mo alamin yung ratio ng dalawang to? You have to do the anti-log kasi nasa loob siya ng log function. No? Sa worksheet na lang ako magbibigay ng ganong problem. Kunwari, given yung pH, given yung pKa, hanapin mo yung ratio nila. So, anti-log yon kasi nasa loob siya ng log function. Okay? So, I will give some examples about that no? In your worksheet. No? Next week ko na i-upload yung worksheet. No? Okay? Paano mo malalaman kung may buffer system ka? Your acid and your salt must be related. No? So, ano yung difference dapat nila? Isang H lang. Kapag more than 1 H yung difference nila, hindi na sila buffer system. And again, yung problem about addition of addition of acid or base sa iyong buffer system, nasa titration na to eh. So, hindi na natin masyado to i-cover. Okay? So, that will be all. No? Next meeting, we will start with the solubility equilibria. Okay? So, yung worksheet nyo, upload ko siya around siguro mga siguro mga Tuesday next week, no? Together with the answers sa quiz, no? Pinagsasabay-sabay ko na para isahang calculation na lang. Okay? So, ganun. So, around Tuesday or Wednesday next week, I will upload the worksheets na and yung ating answer key sa quizzes, no? So, then by March 15 to March 20, midterm exam nyo na. So, Monday yung last meeting natin. That means on Thursday next week, wala na kayong gagawin. Accomplish nyo na lang yung quiz na ibibigay ko. 2 quiz yon. The first part of the quiz will be just about the acid ice table, no? Yung paano mo malalaman kapag acid, yung strength nila, and paano sila i-determine yung concentrations nila. And then for the last part, ito na yung buffer, pati yung solubility. No? Okay, so yun lang. medyo busy week kayo next week, kaya sa Thursday, next week din na tayo magmi-meet, no? Tapos na tayo sa topics na niya. And so, ayan. So if you have any questions, don't hesitate to message me lang, ha? Okay, so that will be all for our session today. I'll see you again on Monday. Okay, so thank you and ingat. No? So upload ko na lang yung copy ng recording sa YouTube. So stay safe and bye-bye.